Hello students, we have a question over here that two charges are placed on two charges plus q and minus 2q are placed on two sides of an equilateral triangle of side A, and we have to find out the electric field at this point A. And if this side is B and this side is C, we have to find out electric field at A. So since it is since it's a equilateral triangle, so each angle of this triangle will be equal to 60 degree. Each angle, this will also become 60, this will also become 60. So if we want to know, let us suppose the E1 be the electric field due to this plus q charge. So as we all know, because of plus q charge, the electric field is always outward. So if we consider this arrow, so this, because of this charge, electric field E1 will be in this direction, and because of minus q charge, we all know the electric field is in inward direction. If it is inward direction, so if we consider this arrow, the electric field will be in this direction, and we have to make this arrow bigger, slightly bigger, because the value of E2 is greater than E1, because this charge is bigger. That's why the electric field due to this charge is bigger. So we can see here both electric field are in different directions, so we have to make components of this electric field to get net electric field at point A. So let us suppose E1 is making angle theta with the horizontal, and if it is making angle theta, and we know this angle and this angle will be equal because these are corresponding angles. So if it is angle theta and it is 60 degree, so let us calculate the value of E1. So the value of E1 will be kq upon a square, because the distance between this A point and B is A, and kq upon a square. Similarly, E2 will become k into 2q upon a square. So the component of E1 in this direction will become E1 cos 60 degree. E1 cos 60 degree. And the component of E2 in this direction will become E2 cos 60 degree, because why because it is also 60 degree angles of a equilateral triangle, and if it is angle 60 degree, then this will also take 60 degree, because these are alternate angles. So that's why this component of E2 will also become E2 cos 60 degree, and this component, this vertical component of E1 will become E1 sin 60, and this component of E2 will become E2 sin 60. But in this case, these vertical components will not cancel out because the value of E2 is greater than E1. So net electric field, if I am redrawing this diagram, so net electric field at point A, because of charge plus q and minus 2q, will become in this direction and in this direction. It will become E1, what we say, the value of cos 60 is 1 upon 2, cos 60 is sin 30, sin 30 is 1 upon 2. So this electric field will become E1 by 2 plus E2 by 2, or we can say E1 plus E2 upon 2. This electric field, horizontal electric field, will become E1 plus E2 by 2, and we know that this electric field is greater than this, so the remaining electric field, after cancelling out this electric field, the remaining electric field will be in the direction of E2 sin 60. So the remaining electric field will be e2 sin 60. Sin 60 is root 3 by 2. So e2 root 3 by 2 minus e1 root 3 by 2. So it will become e2 minus e1 or into root 3 upon 2. So, and the net electric field will be in the direction of this, in between the direction of this and this. So the net electric field at point A, so the net electric field at point A, at A, E will be equal to root E1 plus E2 upon 2 whole square plus root 3 upon 2 into E2 minus E1 whole square. Because as we all know, when two vectors are perpendicular to each other, then the resultant of vector is given by r equal to a square plus b square. We are using that formula here. So this vector ka square root plus this vector ka square. So the net electric field at point A will be this. So if this is the electric field, then it will, if we solve it, then we got just taking, it will become both will give this e1 square plus e2 square plus 2 e1 into e2 upon 4 plus 3 upon 4 into e2 square plus e1 square minus 2 e1 e2. So we will take 4 common, then it will become 1 upon 2 outside. So it will become 1 upon 2 into root this e1 square, to 3 e1 square plus 1, to 4 e1 square. Now 3 e2 square plus e2 square, to 4 e2 square. 2 e1 e2 or minus 6 e2 e1 e2, to 6 e1 e2 plus 2 e1 e2 minus 4 e1 e2. So when we take 4 common, and because of this root, this 4 become 2, and this 2 and this 2, this 2 will cancel out, and we will got e1 square plus e2 square minus e1 e2. And we know the value of e1 and e2. So if we put the value here, then even the value of e1 is kq by a square plus e2 value of e2 is k into 2q upon a square minus e1 is k into q upon a square, e2 is k into 2q upon a square. So we got over here we get k square both here and here also k. So if we take a common here, then it will become outside k because of root. And if we see here, then a to the power 4, a to the power 4 and a to the power 4. So if we take a to the power 4 out, and out of root, then it will become a square outside. So it will, first bracket we will have q square, second bracket we have 2 to the 4, 4q square, and in third bracket we have 2 into minus 2q square. So this is 5q square, and this is 3q square. It becomes k upon a square into 5 minus 2 to 3q square, and we got k root kq root 3 upon a square. This is the net electric field at point A. So E net equal to 1 upon 4 pi epsilon naught and q into root 3 upon a square. And the direction of electric field, and the direction of electric field is as it is 60-degree angle, and the direction of this electric field is at 45 degree from here and 45 degree from here. So this is the direction of electric field. Got it? Because when two vectors are perpendicular, the electric field is between them, so it will lie 45 degree to this horizontal line and vertical also. Thank you.